This is the third in a series of videos in which I'm working on this machine. It's an IBM 6580. It's a display writer word processor system from the 1980s. And in the previous video I corrected a fairly minor fault. There was a shorted cap in the monitor. So I fixed that. The monitor now seems to be working, and we were left with what appeared to be an error code on the screen. I've checked the manual and had a helpful comment that confirmed that it is indeed an error code, and not surprisingly the error code indicates that the unit can't communicate with the floppy drive, which is not surprising because I don't have the floppy drive here. So what I'll do now is reassemble it. I've cleaned the base unit, I've stripped this completely down, cleaned it. This just lifts out, by the way, so if you'd ever need to strip one of these down you can lift this entire unit out, and then the boards just pop out. So I've cleaned all these, checked all the connections, cleaned up the motherboard. There was a bit of corrosion on some of the pins. I don't think they were causing an issue, but just to be on the safe side I've cleaned all those. Checked all the wiring. I've got 3 wires down here that don't seem to go anywhere, but the other ends don't go anywhere either, so I think that's just the way it was made. And given the rest of it a good clean the inside of the power supply. And what I'll do now is get the rest of it clean. This is just a repair, it's not really a restoration, so I'm not going overboard with the cleaning and tidying up. But I'll give it a clean, get it reassembled, and then we'll give it a test. I'll step through the rest of the test procedure and see if we can get through to the end of it without any faults. I have put a scope onto the connection for the floppy drive, and we are getting activity on there, so I think it is trying to talk to the floppy drive. It's just that the floppy drive isn't there, so it's reporting out as a fault, which is what it should do, of course. So I'll get this reassembled and cleaned, and we'll have a final look at it, and that will be this project completed. Okay, that's the unit cleaned up. I've reassembled it. I've gone through as much testing as I can do without the floppy drive, and it does seem to be working. I'll give it one final power up before I finish this series. Before I do that, I just wanted to address a comment that was made. It's a very good comment on the previous video, and somebody asked what the advantages were of having a standalone word processor compared to using a PC and software. And the short answer is, back then, availability. And while we all have fond memories, including myself, of using Commodores and the like with simple word processor systems, they do not compare to a system like this. This was a proper professional level word processor, interlinked multi-user system. You could store data in a proper archive fashion on floppy disks. It was really down to availability of the operating system and the operating software, and this was the only way you could get it. There wasn't the same universal platforms for PC software that we do have today and we take for granted. Back then, if you wanted to develop something like this, then chances are you would have to develop your own hardware as well, and that did make it very difficult, and hence why these things were so expensive. So it's just simply a matter of back in 79, 80, when this was designed and manufactured, there weren't the same options and scope for just writing some software and selling software only. So this really is equivalent to a software package. It just comes with a free machine in effect. Now, to properly put this into perspective, in some recent videos I've been showing some MDS units that Intel developed, and they were for developing systems using their own embedded microprocessors, microprocessor systems. And they were just tools, they weren't PCs, but they're huge, very, very expensive. You needed basically a whole lab to set one up. And these days you could replace an MDS unit with something like this. If you're working on PICs, you would get something like this, just a few pounds, and that's all you would need, PC and some software. But you couldn't do it at the time, and hence the MDS units were developed. But they fulfill the same function as something like this. So that's fundamentally why something like this exists. Products were developing very, very quickly at the time, so just a few years later this would have effectively been obsolete, but this was built in '88, so it goes to show that companies do not have the same scope for making rapid changes that people that are just doing this for a hobby may have. And in fact, the hobby computer market was moving much more rapidly in terms of availability of new devices than they were in the business field. Businesses got first shout, but they were big, expensive, bulky machines. But hobbyists just started using the devices and making up their own systems. You can't really do that in the business environment. I've run my own businesses for many years, and once you commit to a certain technology, you do have to stick with it for quite a long time until you have a very good reason to change. And in fact, somebody commented on one of my videos in which I was restoring a punched paper tape drive, and I said what date it was released, and that was in the 80s. And they couldn't believe that paper tapes were still being used in the 80s. And in fact, they were being used well into the 2000s, and mostly in CNC, not so much in computing anymore. And that was in the business environment simply because they worked, and the capital investment that the companies had made to use that technology was enormous. So they stuck with it because it worked, and there was no reason to change it. I do have a piece of equipment that relates to that I'll be showing in a future video. But hopefully that answers the questions as to why somebody would go to the trouble of developing a standalone word processor system. Okay, so what I'll do now is power this up, and when it powers up it goes through a self-test. I consulted the manual, and as I said, the error 4 is the floppy drive interface failure, but I don't have a floppy drive to plug into it, so I can't test that. I'm getting activity on the port, so I think it's working. It's just that there's no floppy drive there. There's a button on the back. We can step it through the test sequence and change the test sequence if we want to. Okay, so I'll power this up now. It will go into its self-test, show any errors that it finds. But what I'll do is I'll step it through to the next test. If it does stop, there's a button on the back I can press, and I'll move it to the next test step. And then ultimately we should get to the end of the test sequence. It won't boot up properly. As I say, it needs the operating system, which is on the floppy disk, but we should still be able to get it through to the start screen if everything else is working. So I'll get it powered up. We'll wait until the display comes on, and then we'll start stepping it through the test sequence. So we've got test step 4 and error 4. This is a failure of a read of the floppy drive system. I'll step it on to the next test. Test 5, and you can see again we're getting a failure, and it's a failure 05, which is pretty much the same thing. This is the floppy drive interface failure. So we'll step it through again. Let's wait for the test to complete. And now it's asking us if we want to test the left or right floppy drive. So I can change that from left to right and back, and it will then test the floppy drive interface again. But again, it will come back with a failure because we don't have the floppy drive system plugged in. So I'll skip past that. It'll move on, carry on through the test sequence, and then all being well, it will come up with the startup. So as far as I can tell, this is working. It just needs a floppy drive unit plugging into it, and then it should be fully functional. So any questions or comments, then please let me know.